So, in the fourth module of your DDCO, we have a important topic known as direct memory access. So, it is one of the easiest topic here. So, in basic, before starting the explanation, I will tell you, I will give you an idea of what's DMA control. DMA is nothing but direct memory access. So, from the word direct, you can understand that. So, usually, whenever the input device needs some input or wants to give some output, so it has to it has to either take it from the memory or give it into the memory. So, usually the processor is nothing but our CPU. It performs or controls these operations. So whenever it needs some data, it will take from the memory and give to the input, or if you wants to store some data from the input, it will store into the memory. So the work is done by processor usually. But in the case of direct memory access, instead of processor, we have this DMA controller to do this work. So the definition: the transfer of a block of data directly between an external device and main memory without continuous involvement of by processor is called DMA, direct memory access. So how this direct memory access is performed is through the help of DMA controller. So the first line over here says that what is DMA controller? It is a control unit or a control circuit that performs DMA transfer. So let us read this once, and then I'll try and let us try to understand. It is a part of the I/O device interface. It performs the functions that would normally be carried out by the processor. While DMA transfer is taking place, the processor can be used to execute another program. So what does this mean? In this block of part, what we have is, so usually this DMA control is a control unit which performs the direct memory access. So with the help of DMA control itself, we can access the memory directly. So it is a part of I/O device interface. Like we know that we have studied in operating system, between a user and the system, the OS act as an interface. The same way between the memory and the input output, this it acts as an interface. You can also write as like it is a part of the memory interface also. So what, like I said in the beginning, what processor usually does, this DMA controller performs that same action itself. It performs the functions that would normally be carried out by the processor. Instead of processor, this thing performs that function. So while DMA transfer is taking place, the DMA control is transferring the data directly. So the processor does not have to do that job. So it is free at that time. So it can do other jobs. That's what this line. While DMA transfer is taking place, the processor can be used to execute another program. So main thing of DMA is that we can reduce the burden of the CPU or the processor. So as you can see here in the diagram we have over here, so there is this processor, here is a main memory, and there is a bridge between the main memory and the processor. The bridge is nothing but a path, okay. So this is the PCI bus. So here you have two DMA controllers. One is using the Ethernet interface, and the another is for disk, either disk controller or DMA controller, disk or DMA controller, both you have. So here from this this diagram you have to draw, which means, so DMA controller, so from this bridge, right, so whenever DMA wants the access, it will send a signal, and this processor through this bus line itself, it will recognize and allow this DMA controller to access the memory directly. While this thing is happening, so in the bus there will be other things also connected, so the processor will be performing some functions over that device or something else, but DMA will be having the memory access, but it cannot have the access directly. So it has to send some signal up, then only the processor will give the leadership to that. So we will be having a similar topic related to this concept itself, that is centralized arbitrary in bus system. So here usually what for more, if you have to extend, so we can say DMA interface has three registers, first, second and third. So first register is for storing the starting address, and the second is for storing the word count, and the third, which contains the status and conditions flag. You just have to remember this part. One is storing the starting address, storing the word count, and containing the status and control flag. From this registers we will be having a diagram over here. So the diagram over here, which is like, if you just remember this diagram, so this whole part of which we have over here, this whole part can be written only from the help of this diagram. So as you can see here, this is one register, we have three registers. The word count and the storing address, you can keep it empty, but in the status and control, so usually we have taken 32 bit, that is nothing but I guess 8 bytes, right, 8 byte or 4 bytes. So starting address we have over here 0 1, and the ending the 30 and 31st we have some letters written over here. So here we have the done bit, here read and write bit. This is the IE bit. IE bit is nothing but interrupt enable, and IRQ is nothing but interrupt request. So just remember these 4 bits. From these 4 bits now we will be writing everything. So the read and write bit determines the direction of memory transfer. So usually you know that if you want to read something, it is nothing but from the memory we are sending the data to input output, right. So that is reading. So here the direction of the transfer, yeah, you can see the direction. The direction is from memory to input output, and if you want to write, the direction is from the input output device to the memory. So read and write bit determines the direction like this. So you can say here, if it is 1, it means the control is performing read operation, which means the data is transferred from memory to input output. If it is 1, it is read. So you can also remember like that. If it is 1, you can write 1 0 like this. It is above. R by W is there, right? 1 0 if you write. 1 is for read, 0 is for write. So if the bit is 1, it is performing read operation. If bit is 0, it is performing write operation. Read means transfer of data from memory to input output. Write means transfer of data from our input output to memory. So this much is for read. Coming to if done, if the done bit is 1, that means the DMA controller has completed the transfer of block of data and it is ready to receive the another command. So if suppose DMA controller had to transfer some block of data. So if the task is done, then the so task is done. So the word is task done. So the done bit equals to 1. Now the another task can be assigned. So it is waiting for that. So done bit equals to 1 means that. Now we have over here the IE bit and the IRQ bit. So IE is nothing but interrupt enable. So I wrote the IE second, then IRQ first. IE bit is nothing but if IE bit equals to 1, the controller raises an interrupt after it has completed the transferring of a block of data. Raises an interrupt, so it sends an interrupt, so that such that suppose the input device had requested for some access of memory. So now after the transfer of data itself, the processor can execute further, right. So some processor was performing some executing some task. So in middle of the task, it had to perform input output this operation. So for that input output operation, instead of the processor handling the managing the data over there, transferring, so it gives the DMA controller the task to do that. So now the processor should know, right, like it has completed or not. So this IE itself enables raises an interrupt such that the processor can recognize and then take over from there, so that the DMA control will finish the data. So it will take over the leadership over there and then continue with the execution of that particular program. So IRQ equals to 1. If interrupt request equals to 1, that means the controller is requesting for an interrupt. So basically, if IRQ is 1 itself, then IE will be generated to 1. Then at the end, we have request by DMA controller or the device for using the bus are always given higher priority than the processor request. Suppose the DMA, so here you have this diagram. In this diagram, if processor wants to access main memory through the bus, and if DMA controller also wants to access memory through the bus, the first thing the priority will be for DMA controller than the processor. So that's what that last line says, and this is all about your direct memory access.